Hello again. We're going to continue our work on Chapter 7 Homework 4. So let's do it. It says a basketball with diameter, so I have to draw a basketball here, and that's a sphere. 4/3 pi r cubed with a diameter of 9.5. So I'm immediately going to change that to 4.75. Okay, so a basketball with a diameter of 9.5 is in a package in a cubic box measuring 9.5 on each edge. So it's in a box 9.5 by 9.5 by 9.5. Okay, so that makes sense. So here's the box. The basketball's fitting in there perfectly. There's my box. You can kind of see the basketball inside that box. Okay, so the box is technically 9.5 by 9.5 by 9.5 deep because the basketball has to fit inside that box. Okay, determine the volume of the empty space. So this one's actually a little bit easier than this tennis ball problem. I need to find the volume of the basketball and the volume of the box and just subtract the two. So my box is a little easier. The volume of my box is just base times width times height. So 9.5 times 9.5 times 9.5. Okay, so the bottom volume of my basketball box is that. And I'm going to find the volume of the basketball and just subtract. So the radius of my basketball is that. So I take 4.75 times pi, 4 divided by 3. Okay, so when I plug the radius of 4.75 in there, I get 4/3 times pi times 4.75 cubed, or 4.75 times 4.75 times 4.75. Okay, and I get 448,920. And so it makes sense that this is the basketball and that's the box, and this fits in the box, so I just need to subtract. Now it doesn't say round to the nearest. So I'm just going to round to the nearest whole number and double check my answer. So my box is said to be 9.5 by 9.5 by 9.5. So let's do that again. 9.5. That's it. That's my box. Then my ball is the diameter, but I need the radius. All right, that's what I got for my basketball. Cool. So this is my final answer. If you want to round, that's fine. Now let's do the tennis ball. So some of us did this in class actually. I've run out of room, so I'm actually going to scoot over here. You can fill this space. And we're really familiar with this number. So for this question, the volume is my cylinder. So my cylinder is whatever the radius is, and they said that was 4, times my height, which is 24. Because if I had 3 balls with a radius of 4, that would be a total of 6 4s all lined up. So 24 times 4 times 4 times pi. I kind of rearrange those because it makes it easier. So this is my cylinder, or the container. Now I have my 3 tennis balls. So those would be 4/3 pi r cubed. And then I'm going to multiply my answer by 3. So my radius is 4, so I have 4/3 pi 4 cubed. And then I'm going to multiply that whole number by 3. So notice that this is ending up going to cancel. So I really just need 4 times pi times 4 times 4 times 4. And we get 804 for all 3 balls. So to find the volume of the space between, I have to subtract the 2. And it said to the nearest thousandth. So that's what I get. I'm hoping that's right. Now, next question. It says, which of the following would prove that this is in fact a parallelogram? So that's kind of an interesting question. When we know parallelograms need opposite sides parallel. So that means we need the slope of AD to be equal to the slope of BC. And that's what would make a parallelogram, right? Parallelogram. We also know opposite sides would need to also have the same slope. So the slope of DC would need to be equal to the slope of AB. So now, I don't see anything like that here. I see part of it. So they said the slope of AD is equal to BC. Okay, and I like that. And then it says if the lengths of AD was equal to the length. I actually think that would totally work. As long as they're parallel and the lengths are the same, I think that's going to force this into a parallelogram. As long as these slopes are the same and the lengths of these lines are the same, I think that's going to work out. Okay, next question. That's kind of a weird one. 65, it says, please determine the height and length of the parallelogram in the picture. Okay, so this is the parallelogram in the picture, and we need to find the height and the length. Okay, so it looks like the height, we don't want the slant height. We want to drop an altitude. The height is 3, and the length, well, in a way, it's the width. So that'd be 1, 2, 3 boxes. So the reason why I want the height and the width, because the area of a parallelogram is length times width, or you can think of it also as base times width, or you could think of it as base times altitude, right? So the base here is 3, and the altitude is also 3. So the area of this parallelogram is 9 units squared. Okay, so it didn't really ask for the area, but I think that's what it's trying. It said determine the height and length of the parallelogram. Perfect. Next question. It says, which construction shows bisecting a line segment? So when you bisect, you cut it in half. Now, when I bisect, I can't help it but make a perpendicular bisector. So if I'm using a compass and I'm making arcs here, and then I'm connecting where the X's are, I'm not going to be able to bisect a line unless I cut it at a 90-degree angle. So in order to bisect a line segment, I'm going to have that done at a 90-degree angle. So I think 66 is the best answer. This one looks like they cut this in half, bisect to cut in half. Next one. Which correctly states the first 2 steps in constructing a square with a given perimeter? So we kind of did that today. If I knew the perimeter was, let's say, 12, I can think a square has 4 sides, so I know that each side I want to be 3. So I could draw a line, I could sketch a line, and then highlight the portion I'm talking about. So I'm just going to highlight the portion that's 3. And then I could use my protractor, make an arc, and it would make a perpendicular bisector. See how I'm well on my way to making a square? Now I'm going to do that again. I'm going to count up 3 boxes and highlight that section. And then I'm going to twist my paper and do it again. So I can extend the line, and here at this location I can make an arc and make an arc and make another perpendicular bisector and count up 3 boxes. Pretty cool. And I'm pretty much done making my square. So I wanted to make a square that had a perimeter of 12, 3 and 3 and 3 and 3. And I can do it, and what's interesting is I can do it just by following this construction up here. Make it by just repeatedly making perpendicular bisectors and just keep going until I've made my way all the way around the shape. Now here, I don't need to do it one more time because I'm already immediately above there and I have that length right there. So it looks like by doing 2 perpendicular bisectors, it should work. Now that I constructed a square, let's see which one describes it best. So it says, draw a starter line. So I totally did that, but they all have that part, okay? Duplicate a given perimeter, duplicate a given perimeter, duplicate a given perimeter. So they all have that. So I could have stretched out the full 12, and that's kind of what I did when I talked about it. And then it says copy the line segment, construct a parallel line, bisect the line with a perpendicular bisector. Oh, wow. You know what? C sounds exactly like what I did. Lots of perpendicular bisectors. So that's going to be my best answer. Thank you so much for joining us.